And yeah, good morning, good afternoon, and good evening to our incredible global JuiceFS community. Let's see, I think it's sunny today in California, but still a little bit chilly in Berlin. And it's also very early morning now in Bangalore, India. And I know that the AWS Summit is happening there right now. So make sure you're getting some good rest, please. All right, with that said, welcome everyone to the episode 9 of JuiceFS Office Hours, no matter where you're joining from on the globe at the moment. My name is Joe, and I'm a developer advocate here at Juice Data, and I'm your host for today's session as well. And joining me is Ming Tsai, our systems and solutions architect here at Juice Data. So today's episode is a big one because, let's face it, AI workloads are hungry and they're everywhere. And the storage bills can be scary if you're not choosing the right solution. We're diving into something that sounds like magic, but is actually just really smart engineering, right? So 90% cost savings while hitting 70 gigabytes per second throughput. And here's what we'll cover in today's session. So first, Ming will show you how to stop overpaying for your expensive storage systems, especially if you're not fully using them, and show you like how great object store services are. And then we will cover data chunking and metadata separation. This will help you understand how JuiceFS stores data in an object store very efficiently. And finally, multi-level caching. There's a saying that in software, every problem can be solved by adding another layer of cache. But on the other hand, another saying says that the two hardest problems in computer science are naming things and cache validation, right? So you will see how we carefully design the multi-level cache layer to achieve the desired performance. And after covering all these topics, we will have a Q&A session. You can ask us anything you're interested in about storage. And you feel free to start typing your questions anytime during the session in the comment section. And we will answer them all together, in the end. And before we dive in, let me give you a very brief update for our community edition software. So in the JuiceFS community edition, we have a very nice feature, which is the changelog of metadata operations, right? So if that's enabled, you will be able to see, the changelog of metadata operations on that volume. And it's a nice feature to help you inspecting your file system. And also for those of you doing a lot of file or directory cloning, batch clones has seen some solid improvements as well. If you ever try to clone a large directory tree, you know that it can be painful sometimes, right? So our recent changes made those batch cloning much more robust, reliable, and performant. And of course, we have plenty of stability improvements and bug fixes. Note that these changes are currently in the main branch of JuiceFS, and they are very likely to be included in the next release. And for Kubernetes, we have the CSI driver Kubernetes. We have like a lot of improvements too. For example, now we support the cache directories backed by generic ephemeral volumes. So if you're running like in dynamic environments where the mount pods, they come and go, you get the per pod cache isolation without pre-creating PVCs. That is super handy for multi-tenant clusters. And besides, we have a lot of other improvements as well. You can learn more about them in our release notes. Cool, with that said, that's everything from me. Now I would like to invite Ming to take the stage for today's session about AI workloads, performance, and cost reduction. Over to you, Ming.
Okay, thank you, Joy. So can you hear me, guys?
Yes, I think we're good.
Okay, cool. So let's start. Okay, hello everyone. My name is Ming Tsai, Juice Data Solution Architect. And today I'm very glad to be here to have a session with you about how JuiceFS accelerate AI training and inference. Okay. This is today's topic, 4 parts. And from my point of view, I think JuiceFS is a cost-oriented but still high-performance distributed file system. And we will go through for this first. And in the second part, JuiceFS allows you to persist the ability to build a cache layer on demand. Whatever you want with high throughput or with the large capacity, you can build your own cache pool to accelerate the performance. And in the third part, no matter you have cache or not, JuiceFS has already implemented a lot of optimizations to direct read and write to storage. In this section, you will have a brief view of how JuiceFS talks to the backend storage. And finally, we will go through a real-world case, how JuiceFS replaces PFS to provide a free cache pool that with 360 terabytes capacity of 70 gigabytes per second, the caching pool on H100 GPU cluster. Okay. Part 1. JuiceFS are cost-oriented distributed file system. Yeah, I think JuiceFS is a cost-oriented file system. Why? Because it's unlike traditional file system like kernel file system like GPFS or Lustre. JuiceFS is just built on the top of object storage. It can leverage its cost effectiveness and scalability, which could be several times cheaper than traditional file system. And why we say it's still a high-performance file system, we all know that about object storage has the weakness of high latency. It would even terrible in some small file scenarios. Don't worry, JuiceFS takes care of it. First, JuiceFS decouples the metadata from storage data, which you can use dedicated engine like Redis or TiKV to support heavy I/O node, such as massive random read writes with high concurrency. And secondly, for the data acceleration, we have implemented a lot of features like read ahead or prefetch data. Sometimes you can choose. Sometimes you can just choose directly read and write to object storage, especially the workloads that are mainly sequential read and write. Yeah, but if you have higher performance needs, such as in massive random read and small file scenario, cache nodes can be added on demand to form a cache pool for applications. And the point is that all these are up to you, up to your workloads. So the result is that JuiceFS uncoupled the I/O performance with the storage capacity. You don't need to pay extra to meet throughput or IOPS requirements for storage. So if you are looking for a file system that cut down the cost while still meet the performance requirements, you should take a look at JuiceFS. Okay, next, let's dive a little deeper in the selection of AI storage. The most common type is NAS, with typical representative including AWS EFS or FSX for Lustre. These are out-of-box products that you can mounted, that they can be mounted directly using NAS or Samba protocol, even without installing native clients. However, there are several typical issues here. First, they are expensive, and then the performance is cool, but they are not good enough. And the third and the important thing is that NAS, PFS storage like this, performance and capacity are tightly coupled. For example, if you need 10 GB per second throughput, you have to purchase a corresponding amount of capacity. Sometimes you have to over-provision just to meet the throughput requirements, which is not flexible. And we say if NAS is designed for convenience and is suitable for scenario, don't need a crazy capacity or speed. But if your data starts exploding object storage is a nature choice. Why? The answer is very simple. It's very cheap. But object storage also has its limitations. And you can see here, first, they only speak GET3 protocol. Your standard POSIX application will need a translator to work with it. Plus, it wasn't born to handle stuff like ls, state, or rename. If you try forcing to use them on object storage for this kind of I/O, it will be very, very slow. And the second, thanks to being immutable of object storage, it doesn't do read and write or append. If you want to change one tiny byte of your file, sorry, you have to overwrite the entire file. The write amplification is just brutal. Okay, the third one is object storage has a high latency, no cache. The performance is entirely depends on the object storage itself. And if your workload is almost sequential read and write, that will be okay. But if it's a massive random read write or totally small file scenarios, that could be a nightmare. Okay, and then how can we fix all those that I just mentioned? Let's see what magic JuiceFS does. First off, JuiceFS is a pure software solution. You can just install it as a process right on your business machine, on your GPU or CPU nodes. Once it's running, you will get a POSIX mount point to your computer. And it looks like and feel like just a local drive, a path that you can access, even though the data is actually living far away in the cloud. And then we split everything into two parts. First is access object storage by native Go API or GET3 protocol. You don't just bump big files here. We slice them into small blocks and transfer them concurrently. This design makes the performance fly. Sometimes even single file upload or download can reach the throughput limit of object storage. And then on the other part is metadata engine. We decouple the metadata server away from storage. It knows exactly where every piece of your file is, and it handles all the ls, state, and the rename stuff instantly. You no longer have to wait for the slow object storage to do this job. And more important is that this design supports read and write and append write on object storage. Any change on existing file will trigger a new upload of blocks and then update the metadata. That's all. No more write amplification. And I think this might be the most important charts in today's session. So if you get this architecture, I think you can get to know JuiceFS. Okay, and here is a comment from our real customer that if your data is under tens of PBs, you might have choices. But when you hit the hundreds, billions of files or hundreds of PBs capacity level, such as autonomous driving, robotics scenario, object storage might be your only way out. And JuiceFS is the engine that makes that actually work. Okay, let's go to part 2, on-demand performance acceleration. So I think storage in this chart is just like feeding the beast. The beast here means in the top, the high-performance GPU or CPU. And we know that object storage is relatively slow, but your GPUs are hungry. How do we close that gap? We use the left. You see here in the middle green chart that we use the leftover RAM and local NVMe disks from your GPU nodes and put them together. I'm thinking of it as building a huge distributed read cache for your data right next to your client nodes. And the cache layer, you see in the gray part like a bridge. Remote S3 storage is miles away, but AI training needs data now. JuiceFS acts as a high-speed bridge. We use asynchronized prefetch to put data in advance, so your GPU will not have to wait. You will not have to waste the time to wait for the data. And more important that it allows you, you can scale your I/O performance whenever you want. If you need more speed, just add more cache nodes. That is to say, you don't have to buy more storage capacity just to get more bandwidth. They are totally uncoupled, and you can build your own cache pool. Okay, the part 3. Now the problem comes. Some guys will ask, what if we don't have we don't have cache resources to speed up? Is the JuiceFS still fast? I think the answer is yes. Here is how we handle your data directly. And first, you can see the chart in the left. Instead of sending one giant file, JuiceFS slices it into blocks and upload them using multiple threads. Sometimes download a single file can max out your object storage bandwidth. And besides, we have implemented a lot like read ahead, prefetch feature to further speed up the read performance. And second, we solve the write amplification problem like I stated before. Previously, we have to upload a whole file, even if we just want to append a little to a file. Now we only replace that specific block and then update the metadata of this file. This could save a massive amount of time and network waste. And finally, I will talk about the consistency. We keep everything consistent. That is because the only way you can access your data is through JuiceFS client, no matter Perfect client or Python or Java SDK or S3 gateway. They are all kind of JuiceFS client. You can only reach your data through JuiceFS client. User cannot change them direct on the object storage side because you can only see the raw block file there. So in this way, by this design, it can make sure that what you see is always the latest version from your client. So for the conclusion of this page is that we say even without JuiceFS, even without cache, JuiceFS can provide a good performance on top of object storage, especially in some sequential read and write scenario. Okay, now let's talk about this real story in the part 4. How JuiceFS replaced PFS to provide a free cache pool for customer AI workload. And take a look at this setup. We have 6 H100 GPU nodes here, 60 terabytes of fast NVMe storage for each, and a massive network bandwidth. And the point is that this customer didn't use this resource at all. They are totally unused. So this is a dream setup for JuiceFS to build a distributed cache. Okay, and previously customer would use AWS FSx as a middle layer between their training cluster and S3 storage. That is cool, but there are 2 major pain points here. First, FSx is very expensive. It's near 10 times more expensive than S3. Secondly, its most annoying part maybe the performance is strictly tied with its capacity. If you want more speed, you are forced to buy more space that you don't even need. It's just like forced to buy a bigger house just because you want a bigger kitchen. They are coupled. It's not flexible. So by these 2 pain points, customer spent got a lot of money, but the GPUs are somehow still left waiting for data. And the problem is that if the workload expand, customer may need to pay more money. Okay, so here is the JuiceFS come to solve the problem. And we change to the JuiceFS solution. The results here look very remarkable. Yeah, we took those same 6 GPU nodes and did something smart, is that we used their unused existing NVMe disks to build a giant, totally 360 terabytes distributed cache. And we use them 100 Gbps network adapter on that. So we didn't buy any single new hardware. This is why I called it free storage. It was already there, just sitting idle. We use them. And let's look out the let's look at the engineering math on the right side. We by putting these nodes together, we unlocked a massive 70 GB per second read throughput. And the best part is the network overhead is tiny. It's only about 5%. So you get all that speed almost with no tax on your system. JuiceFS can provide a 95% utilization for 100G network adapter environment. So for this customer, he was very satisfied that JuiceFS just replaced the FSX here. We leverage the existing resource on H100 GPU nodes that unused before, and significantly cut down the expense by 90%. Okay, maybe you just wonder 70 GB per second is still not enough in your workload. You may need more. Can JuiceFS handle a really, really big cluster? What is the limit? Well, let the data speak for itself. So before that, I can say 1.23 terabytes per second is not a yes limit. We test on that, and if you have more resources, JuiceFS can be better. So let's just look at the yellow line on the chart. We reached an aggregated throughput, of 1.23 terabytes per second. Terabytes per second, yeah. To put that in perspective, we were running on 100 nodes with each 100G BPS network limit, and we achieved over 98% bandwidth utilization. That is remarkable. But that is not just about the raw speed. It's about the efficiency, and you can see the terminal screenshot on the left. You can see the CPU usage is very slow on client nodes, only about 0.8 to 0.9 cores per GB per second. This means JuiceFS doesn't consume much GPU resource, even if in extremely high throughput workloads. And we also verified 7 million IOPS, which is credible for our distributed file system. So for this chart, the takeaway is very simple. It's simple that whether you have 6 nodes or 100 nodes, JuiceFS scale linearly. If your AI mode is hungry for data, this is how you feed it at full speed. Okay, recap. The last page. Let's recap for today. From the beginning, I said JuiceFS is a cost-oriented but still high-performance distributed file system, right? The cost-oriented here is that JuiceFS built on the top of object storage, which is naturally very cheap. And if you have performance need, you can also add cache nodes on demand. Of course, if you don't have additional resources for cache, you can directly read and write to object storage. because object storage is fully capable of handling sequential read and write operations. So refer to the basic logic how JuiceFS can accelerate the performance. Here are the three parts here. First, for data, local cache or distributed caches that near to your GPU nodes can provide a low latency, high throughput read performance. And the importance that is on demand. For metadata, you can see the dedicated metadata server is used to support metadata semantics and massive I/O nodes. And the third one is naturally JuiceFS slice the file into blocks, cut down the write amplification, and further optimize the performance with our design with the read ahead and the prefetch feature. So, so we still have a lot of work to do in the future. The first thing that we plan to add RDMA integration. And I think this already released in 5.3 enterprise edition and by RDMA support, we have more utilization for large bandwidth network adapter, like 200G or 400G racking adapters. And in the meantime, the point is that it could further drive down the latency and the CPU utilizations. So another one is block device support. Yes, what we talk about the cache is about the reader cache, and in the future, we plan to support more for this block device. It can be used to speed up the random writes and the very small files writes. And for detail, you can refer to the roadmap on our website. Okay, this is all what I have for today's session. And thank you very much for your time. Thank you, Joy.
Awesome. Thank you, Ming. Yeah, it's a great breakdown of JuiceFS, the comparison with other solutions for folks that are handling AI workloads. And yeah, thank you so much, Ming, for this session. And yeah, we will see if we have questions coming to the live chat or to the comment section. Yeah, no matter where you're viewing this session, yeah, please now is the time to send us the questions. And yeah, we'll give it a few minutes to see, because I know developers are always shy, and they sometimes shy away from sending the question right now. If that's the case, that's fine too. We will tell you how to keep connected with us. But yeah, if you do have questions related to file systems, object store, JuiceFS architecture, stuff like that, yeah, please let us know right now. Okay. Yeah, that's we have some questions coming. We'll see some of those. Yeah, so the first question we got is, did you compare it with S3 files? S3 files can also mount. Yeah, that's a great question. So I think I can take this one. Ming, let me know if you have something to add. So for those folks who don't know, S3 files is a new service that AWS recently launched. So what it can do is that you can use your if you have like an existing S3 bucket and if you want to use it as a file system, then you have the option to do that directly with AWS. So it's a great solution. It's built on top of the S3 and AWS EFS, Elastic File System, right? So it's a great solution if you're already on AWS and if you want to try to use the POSIX API to access your file. So on one hand, it's very easy to get started with. On the other hand, you need to be careful with the pricing and the performance, right? So in terms of pricing, whatever you stored in S3, that's the same pricing. But if you have data that's being written or like read from S3 and kind of cached in EFS, then you get charged for that portion using the EFS pricing. That's around I don't remember, like 60 cents per gig. Yeah, I need to check the details. So yeah, so pricing wise, you get charged by whatever being stored in the EFS layer. So that's one thing. Another thing is that by default, when you import a bucket or you import like let's say it's actually called prefix, right? But you can think of them as like sub buckets in your bucket. So if you import one of those, by default, S3 files is optimized for small files. So it will synchronize the metadata, and it will only pull files smaller than 128 KIB into the EFS layer, which means that that's the default setting, which can be adjusted, but you can tell that it's kind of more optimized for smaller files, right? And for large files, because let's say you have like a gigantic video, that video is one object in S3. So if that's the case, then S3 files doesn't help you a lot in terms of the performance. It still needs to read from S3, and yeah, that's how it is designed. So to me, it is a great smart solution. Yeah, the drawback is like you need to be careful with the pricing, and second, when you are working with like large files for your AI training, you need to be careful as well. Actually, we will be releasing like a blog post soon talking about S3 files. Yeah, so overall, we think it's a great solution if you're already on AWS, and yeah, you just need to be careful, read the documentation before you settle on like any solution. Yeah, so that's my take on it. Yeah, and also if you're not on S3, or let's say you have needs for multi-cloud workloads, right? So if that's the case, S3 files doesn't help a lot in that case. Yeah, whereas yeah, in JuiceFS we have plenty of solutions like distributed cache or mirror file systems that can help you with the multi-cloud workloads. Cool. So yeah, obviously there are like more details. I couldn't cover like all of them, but yeah, no problem. It's a great question. Thank you so much, this community member of JuiceFS.
Yeah.
Cool. Yeah, let's see if yeah. Also, I also figured something like very interesting. Actually, Ming wrote an article on this, and we are in production with we're like producing the blog post, and it will be released very soon. One thing I find very interesting about S3 files is that when you write directly to S3 files, right? So it will stay in the EFS layer for a while, and then it will be synced down to S3. So as I mentioned, the storage in the EFS layer, it will be charged. And then whatever you write and read from the EFS layer is also going to be charged. But let's say when you write a file, so that's a write. But when S3 files needs to sync that file down to S3, it actually does a read. That read is also charged, like you also get charged, even though you technically didn't read it, right? Like you're writing it, but there is a write in EFS, then there's a read from EFS down to S3. So something interesting to consider, yeah.
Yes, and I think in spite of the price, I think the total differences between these two file systems is that JuiceFS splits the file into blocks, while S3 file doesn't do that. I think that is the major difference between these two kind of file system, and that is to say the consistency is not the same, because if you change the file system, if you change the file in S3 file side, while the file changed in the object storage side, the conflict will happen. So the conflict will happen, and the S3 side will be the single source of truth, and the EFSC files will be replaced. Yeah, that will be the major differences, I think.
Cool. Yeah, that's a great point too. So yeah, so because S3 files try to maintain like a one-to-one mapping, right? So you can always use S3 files to do the read and write. You can also directly read and write your S3 object. So there could be a conflict. And it's one-to-one mapping. So if you have like a gigantic file, it's also one-to-one. In JuiceFS, you are not supposed to read the objects managed by JuiceFS. You should always read from the JuiceFS client, meaning like the POSIX API. That's by design, and by doing that, we have like open to close consistency, and also for large files, it's chunked to like many pieces. And when we do upload or when we do pull from S3, it's in parallel using multiple threads. That is how like we are able to achieve, the numbers shown by Ming. Like it's very impressive throughput there. Cool. That's one thing. Another question we got here is, how much storage size can JuiceFS be scaled? Can it be used on HPC like GPFS for parallel computing jobs? Yeah, that's a good question too. I think let me find I need just to look. So yeah, there are a few, like we have the community edition and the enterprise edition, right? So I don't have the number in my head right now for the community edition. But for our enterprise version, we are like the newest version 5.3. We are talking about things like 500 billion files. So it's more about the number of files because that's what the metadata engine needs to deal with, right? And in terms of the volume itself, I think that's kind of unlimited in my mind, because with 500 billion files, no matter how large each file is, we do the parallelization, like the chunking for each of the files, right? So the volume itself can be like really huge. Yeah, so that's some of the number I can share right now, and I can find more details for you later too. Regarding the community edition, or and also depending on the workload and the setup, how you actually use it. Yeah, those factors needs to be taken into consideration as well. As for the second part, can it be used on HPC like GPFS? So yeah, we do have plenty of customers that approach us to replace their HPC because of like cost and volume, right? So that's a very positive signal, I would say. And I think Ming would have more maybe experience or examples of like the customers you worked with like are they doing that? Like how are they replacing their HPC solutions?
Okay, cool. So for this answer, the simple answer is big yes. Yeah, I think, but yet still depends on the workloads. Because if you have so many random writes, that I can say maybe it's not very good for JuiceFS. But you in the AI workload is read workload more than write workloads, and I think that's very suitable for JuiceFS to replace GPFS. And I think we have already a lot of customer in China. In China has a lot of OEM company like CPFS, VPFS. That is the OEM version of GPFS, right? But they are very expensive on cloud. So a lot of customer reached us to replace them. And in the result that the performance is very good. We can provide terabytes per second throughput by the distributed caching pool. So yeah, the answer is yes. As long as you don't have massive random writes, and I think the file system of JuiceFS based on the object storage can handle HPC workloads. Yeah.
Great. Thank you, Ming. Great answer. Yeah. So, you can tell we're like real engineers, so we know the trade-offs, right? Like we don't say that it's like the best in every aspects, because in engineering it's always about trade-offs, right? So, as Ming mentioned, currently we're better with like read-heavy workloads, but yeah. In many places, we will continue to improve and optimize. And yeah, if you're interested in specific workloads that you have in hand, yeah, maybe you can reach out to us and we can have a chat, because file system, like it's a simple API, but it's very flexible to use. Like people use it in like millions of ways, right? So yeah, that I think that's the beauty of engineering as well. Like when something is simple and elegant, it's used in like many creative ways, and sometimes maybe misused. So yeah, we can chat on that if you're interested. And we do have we have a comment here. I think that's by Ray. It says to answer the question for CE Community Edition, we have users like managing a couple hundreds of PB in a single volume. Yeah, that's a great use case or case study there for you too. Awesome, that's nice. Let's see. Oh, those are really great questions. I feel like personally I like this kind of discussions, because it helps me understand like JuiceFS or maybe other storage systems and database better every time. And I hope that's helpful for you too. So yeah, so thank you for this community member. You're saying you're working on Jane data, and so you don't use the cloud for storage because of the PHI. Yeah, that's okay. That's understandable, and even like everything is on-prem. You can have like good solutions for object store on-prem too. And then, JuiceFS just adds a layer of POSIX on that. So that could be an option for you too, if you're considering. Yeah, and the beauty of it is, I would say it's much easier to scale, even if it's on-prem, right? Because typically the object store services like Minio or like some others, if you want to add nodes into the object store, yeah, I would say it's arguably much more easier than hardware software bundled solutions. And when you add like more machines to your object store, like you're essentially adding more volumes to JuiceFS as well, but you don't need to do anything on our end, right? So, yeah. Cool. So without, okay, so the follow-up question is without relying on cloud providers object storage. So yeah, as I mentioned, like there are plenty of on-prem solutions for object store as well. And some of them are software based, some of them are like software hardware bundled, like Pure Storage. Minio is like software solution. So what's nice about it is that, as I said, if you manage that, then you're managing object store, and it's easier to scale. It's easier to add machines, and that also adds volume to JuiceFS if you run JuiceFS on top of that, right? So yeah. Stir, yeah. Cool. All right, let's see if we have more comments. Cool, no problem. Yeah. I like storage, and I like different kinds of storage systems. And to your question, if depending on like what you use, right? Like AWS, the entire AWS can be on-prem too. It's called AWS Outposts. So if you get license of that from AWS, you can basically install all the services of AWS on your on-prem machines, including S3, right? But that might be an overkill in scenarios if you don't need all those services. But that's an option too. Just so you know. Yeah, it's the same for other cloud providers. Like you can install the entire GCP on-prem too. Yeah, like they do that. They do provide services like that. Cool, awesome. I think we're at time, and yeah, let's see if you have like one more questions. It's the last call for today, but it's not the last call for for tomorrow or anytime else. If you want to get involved with us, I know URLs are hard to read, but if you Google JuiceFS or Google or use your AI search engine too, right? Like if you search using whatever tool, JuiceFS or just data, you will be able to find us. We have our website. We're on GitHub. The community edition is fully open source, Apache 2.0, forever for free. Yeah, and we have a Discord channel too. That's not very easy for you to capture right now, but if you go to our website, it will be much easier to find the Discord icon, and you click on that, you're joined. And yeah, we talk all different kinds of topics or like issue discussion, and we do have like very active contributors there as well. You may think that the crowd on our Discord server is not that large because we recently migrated from Slack. So yeah, that's just the reason. But yeah, we welcome everyone to join to make the crowd bigger and share more interesting thoughts. Cool. Okay. With that said, I think we can conclude today's session. Very nice session. Thank you so much, Ming. And
Thank you.
yeah, and we'll see everyone next time. And this video will be uploaded to our YouTube channel as well. All right. Thank you so much. Have a great one. And tomorrow is Friday. Have a great one. Cool.
All right.
Bye.